Hi, welcome to another episode of Out of the Blue. Today, by special request, we're going to be talking about dark matter. And this is another one of those things that I don't want you to feel like you can't learn, because it's not that difficult to think about, and I'm going to take it slow, and we're going to learn all about it. Ready? Let's get started. The best way I can think to explain what dark matter is to explain how scientists came to the conclusion that it existed. And to do that, we're going to have to talk about our Milky Way galaxy. Now, I have a tiny model here just to use it to talk about it, and I want you to think of this as our Milky Way galaxy. So just pretend that there are spiral arms here full of stars and dust and stuff, and this bulge at the center represents an actual bulge in our Milky Way galaxy caused by the supermassive black hole at the center. That's what's keeping us all in, that's what's keeping us in the arms and stuff like that. Now, because the bulge is so massive and it has a black hole and it has a bunch of stars and dust in it, scientists used to think that most of the mass of the galaxy was centered at this bulge. Now, when you have a mass that has most of its mass in one place and another mass that has most of its mass in one place, you can calculate how long the second mass is going to take to orbit around the first mass based on their distance apart. It's a really simple mathematical relationship, and the period of the smaller object around the larger object squared is equal to the distance of the semi-major axis cubed. If that's too complicated, don't think about it. Just remember that there is a mathematical way to figure out how long it takes something on the outside to circle what's on the inside if you know the distance between and if most of the mass is centered at the middle. Well, in our galaxy, there are some outer galaxy things that are orbiting around us, just star clusters, clouds of things, just stuff that's on the outside that's not in the arms, that's pretty far out. Well, scientists wanted to study these things, and to do that they were trying to calculate the period. Well, they came up with a period based on most of the mass of our galaxy being in the center, like it appears to be. And they came up with a period that didn't match at all what the outer clouds were doing. And the only explanation for that was that most of the mass wasn't centered at the center of our galaxy. And you can even see, if I took off the Play-Doh from this CD, it would be a lot lighter. Most of its mass is at the center, and this CD doesn't have a black hole in the middle, adding more to that. So they weren't quite sure what was happening. I'm gonna not shine that on you. But they figured out that most of the mass couldn't be centered at the center of our galaxy. And in fact, there was so much mass keeping this thing out on the outside spinning so fast that we couldn't account for all of it with everything that we have visible. Even if we added all of the things from all of the spirals, it didn't add up to enough mass to keep the things on the outside spinning the way they were. Now, that means there's something adding mass to our galaxy that we can't see, and scientists decided to call that dark matter. The most prominent theory in what dark matter actually is just that it's a new type of matter that we don't fully understand yet, that doesn't react to electromagnetic radiation, aka light. That means it doesn't emit light and it doesn't absorb light. Now, if you're wondering how we know it's there, we use the cloud type thing before to figure out its gravitational effects on matter that we can see. Now, there's so much dark matter in the universe, there's more of it than normal matter, that its effects are really, really big. So basically every galaxy that we've observed has what's called a dark matter halo around it. So our Milky Way galaxy has a halo that's about this big around it, full of dark matter. And that dark matter just adds a lot of gravity that keeps everything spinning and keeps our galaxy together, but it's matter that we cannot see. There are sort of webs of dark matter that keep a lot of galaxies together, and every galaxy has a halo, and there might be sort of dark matter strings in between that keep that together, and it's all just a cosmic spider web that's made a bunch of galaxies, and we're not super sure about that, and there's a lot of research going into that right now, so if that's a little complicated, don't worry about it. And dark matter is really new. It's a new subject. Scientists aren't super sure on it. They're trying to do experiments, and they're trying to improve the standard model to account for dark matter. But it is something super new, and it's another thing that our generation is definitely going to have to figure out. So I suggest you get started on that, because it's pretty fun and pretty interesting. What we're doing here today is barely scratching the surface of what dark matter is. And part of that is because we're all beginners here, I think. And the other part is because scientists themselves are barely scratching the surface of what dark matter is. We're barely figuring out how our universe works and what the mechanics are in working that. And I want you to stop thinking of science as like Newton was sitting under the apple tree and he discovered gravity, and start thinking of it as something that's now. It's happening, and we need to improve it. I mean, science is still going on. We're still figuring out so many things, and we can be a part of that. And I think that's great. So, yay for science, and I'll see you next week.